The world's largest truck factory is located in Wörth am Rhein. Here, a new truck rolls off the assembly line every 130 seconds, up to 470 trucks a day. The factory in southern Germany exports its vehicles to all corners of the earth. The site is huge, almost the size of a small city.
If you want to visualize it, think of 400 football pitches. That's 2.9 square kilometers. That's pretty big.
The list of different vehicle versions you can order is huge, as is the range of colors. There are more than 450 to choose from.
Sometimes our customers come with color samples and ask to have that particular tone. And that is how we end up with such a large number of colors.
Since its introduction in 1996, the Actros has become the factory's most produced truck. It is the classic tractor for highway transportation. The engines come from the company's own factory in Mannheim.
The engine is wonderful. They should all be like that.
One truck every few minutes, the largest truck factory in the world. The Mercedes-Benz truck factory in Wörth. Almost 11,000 people work here, producing trucks for the whole world. 1 of 5 trucks in Europe comes from this factory. In Germany, it is every third one. The first truck rolled off the production line in 1963. Powerful and robust. Fast. Economically reliable for every job. Kilometer after kilometer. That is how the vehicles with the Mercedes-Benz star prove their worth on 5 continents. A lot has happened since the 60s. Production no longer means strenuous manual labor. Today, robots weld the truck cabs. Machines are taking on more and more jobs, reducing the burden on employees. High-rack warehouses are stocked and unloaded by robots. Truck assembly is like a giant 3D puzzle. Every day, around 550 truckloads of parts come in. Everything from tires to radios. All these things are assembled in the various production halls, and in the end, a new truck rolls from the assembly line every 130 seconds. These chassis beams are the basis for every truck. Several hundred of them arrive at the factory every day. Every vehicle frame needs 2 of these longitudinal chassis beams. These 2 elements are bolted onto cross members. The frame used here has a large number of holes so that it can be used for a wide range of vehicle types and versions. At the front, the structure finishes off with the so-called frame head. The frame has already been marked to show which bolt goes where.
The markings for the bolts are done by laser. They are marked up here by the laser system. The laser markings tell the employee exactly which bolt with which diameter goes into which position. The frame construction, which is carried out at the station, uses around 300 to 400 bolts per frame.
It is the basis for every truck that leaves this factory. The finished frames weigh several hundred kilograms and can only be moved with the help of automated transportation systems. This is where the journey through the huge hall starts. After about 6 hours of assembly, a finished truck leaves the factory. All cables are secured to the frame by means of cable ties. It is already clear which parts will be added. For example, what kind of accessories the truck will have, which brakes will be used, and which rear axle version. There are more than 400 colors, a wide range of engines, transmissions, and bodies. The gigantic number of possible combinations means that there are very few identical trucks built here each year. To ensure that the assembly line always has the right parts in the right order, they are always put together for a specific vehicle. The assembly line should never have to stand still, and there should never be a wrong part. Going back to look for a mistake wastes valuable time. In this step, the so-called picking, all the parts are put together for the next vehicle. An employee sorts them into his basket in the exact order in which they will be used in production. Green and red lights show where the next part can be found. Only when all the necessary small parts are in the basket does the system give a green light. Frame construction is the first station in the huge factory. This station alone is 1 kilometer long and has the size of 10 football pitches. While the frame is being assembled, the cabs are being put together here. There are 550 different versions. Every cab consists of a base plate, the sides, and a roof. Computer-controlled robots put the parts together. The complete cab is now welded, fully automatically and with millimeter precision. Then the driverless transport system moves the cabs onto the next station, the verification, as if by magic. A special camera system uses 150 reference points to check every cab. Only if everything is perfect is the shell allowed to leave the station.
We have our inline measuring system outside, where all vehicles are measured. If anything unusual is found, then the cabs are remeasured, using up to 1,000 attributes.
The factory has a special measuring station specifically for this. The measuring machines here work with lasers that provide an accuracy of 0.05 millimeters. They show if the size and space between the holes and threads and surfaces are correct, so that the employees can tell if the cab is assembled precisely as it should be or not. Only after a successful test can the truck continue on its way. Next, the cabs come to the paint shop. There, each cabin gets a primer coating by passing through a dip tank. It is the most important paint job in the life of a truck, because this layer prevents rust. Doing a half-forward roll, the cab is submerged in the paint. This ensures that there is corrosion protection in every nook and cranny.
If we simply dipped the cab, there would be a pocket of air that could not escape quickly enough. By turning the cab, we have changed it so that the air can escape, can get out of the cab.
The cab and the paint have different charges, so that they attract each other like magnets. The primer has an optimal adherence to the cab. This process is called cathodic immersion priming. Once the primer has been applied, the cab moves to the next station, PVC seam sealing. Robots apply PVC to seal all of the welds and cutoff points. Every opening is perfectly sealed, preventing any moisture from getting into the vehicle. Another coat of paint is applied, once again using electrodes. The atomizer is positively charged and the cab has a negative charge, so that the cab practically pulls the paint towards it.
These are high-rotation atomizers driven by turbine. It has a certain rotational speed and sprays out the paint accordingly. On the outside, there is a high-voltage field that makes the system very efficient and reduces the amount of material we have to use.
Only 4 liters of paint are needed per cab. The system paints the doors and add-on parts along with the rest of the cab to ensure they have the exact same color. The paint is completely dry after only 45 minutes. Every coating is then checked with the utmost precision. The color blue comes in 40 different shades. Employees have to make sure they have a good overview of what is going on to ensure that each customer gets their truck with the exact color they wanted.
Sometimes it happens that our customers come with color samples and ask to have a particular tone, and that is how we end up with such a large number of colors.
Back in the assembly hall, the frame construction is finished. At the moment, the frame is still upside down so that the axles can be lowered onto it. Several hundred screws and bolts hold this skeletal structure together, a structure which will later support the entire truck. These heavy frames can only be transported to the axle assembly with the help of a gantry. Now the axles are installed. Depending on the type, each axle can weigh up to 900 kilograms. The axles will eventually be responsible for accelerating and stopping the truck. They are especially designed to deal with these daily strains. The men on the factory floor can only lift these pieces with the help of an engine hoist. Very carefully, they lower the axle down onto the upside-down frame. Then the chassis is painted. Nova Gray is the standard color. At the customer's request, any other color is also possible, such as red for the fire department. The frame is not turned over until the color has dried. Now the axles are facing downward. And the truck is ready to move on to the next station. Here, the diesel engines and the transmissions are already waiting. The men in the factory lovingly refer to this step as the engagement, because it is here where the frame meets the engine that 2 of a truck's 3 most important components come together. The frame is now the right way up. The men can now slowly lower the heavy engine and attach the 2.
This is where the engine, which was delivered from Mannheim, is put in. We carry out a small pre-assembly and then insert it into the frame. This is what we call the engagement. The wedding takes place a few stations further on. That is when we put the cabin onto the frame.
The Actros engine is available in 10 different versions, from 328 horsepower up to 625 horsepower. The 6-cylinder diesel engines consist of around 2,500 individual parts. They are built in Mannheim, in their in-house factory for commercial vehicle engines. First, the engine block is put on a so-called AGV, short for Automated Guided Vehicle. An AGV is a driverless transport vehicle. The engine now has an automatic chauffeur that transports it from station to station. Once the sliding bearing surfaces and the crankshaft crankpin are oiled, is the crankshaft mounted on the engine block. Then comes the 6 pistons with the connecting rods. They are all put in by hand and bolted to the crankshaft. Every piece that is mounted on the motor has its own article code, which is stored in the system. Before they are mounted, the employees scan the pieces and check to see if they are the right ones for that motor. All the pieces must be mounted, otherwise the AGV will not transport the motor to the next station.
As soon as the engine logs on at the station, the employee is shown which component he has to take out and how many. That means that in this case he has to take out 2 clamps. When he does this, the white light turns off and the green one turns on and blinks. So if the person working here forgets to take out a part, then the engine does not leave the station and he notices, oh, I forgot something.
Scanning the individual parts allows to trace things back in case there is a complaint. Even the force with which the screws are tightened is saved in the system. This is the code for the flywheel. The code is now assigned to the appropriate motor, the part is put in and checked by a scan. After the exhaust turbocharger with the exhaust manifold has been pre-assembled, the block is hoisted onto the cylinder head, mounted, and bolted. Next, someone checks if all the cables are routed correctly and all connectors are connected properly. This is done with the help of a tablet.
Then we scan the barcode from the controller in order to be sure that we have the right engine. Then the employee is shown various components. That means he works through the checklist. If that's okay, then he can set it to OK. For example, he checks to see if these locking components are properly set. If that were not the case, the vehicle would probably survive our test run, but eventually fail in the field. That's why he checks every single connection to see if they are secured, and then he marks them with a yellow paint pen so that we can be sure that the cables have been correctly mounted.
Before the engine goes to the in-house testing facility, it is examined one more time according to a method adopted from Japanese production facilities. An employee grips each component in a precisely defined sequence and checks it with his fingers and eyes from different angles to see if the parts have been assembled correctly. If everything is okay, the AGV brings the engine to the testing facility. A robot takes the engine and carefully lifts it onto a dedicated testing facility transport vehicle. Now the motor is waiting for a vacant test bench. Computers determine the sequence in which the motors are tested so that there is no idle time at the test benches. As if by magic, the AGV with the engine moves towards the next available test bench.
The AGVs have a conductor loop, meaning that they draw their energy inductively, directly from the ground. There are lots of markings on the ground that the AGVs use for orientation. They then count the number of wheel rotations in order to know exactly when they need to turn, to drive right into the test bench. Before one of these AGVs drives into a test bench, it has to lift up the engine.
The test bench has a higher working height. For safety reasons, the vehicles use a very low center of gravity while driving. The test bench. Up to 4 engines are tested here per hour. To reduce weights, a turntable system is used. While one engine is being prepared outside, another one is being tested inside. When the one inside is finished, the next engine can be brought in and the test starts immediately without any waiting time.
The 11 test benches carry out both hot tests and cold tests. We use both variants, and there are only 11 test benches because they are so effective.
The engine is attached to the test bench and filled with water, oil, and diesel. Then each engine goes through an automated performance program. This is the first time the engine is actually started. After the test, the engine is checked for leaks. An employee goes over every part one more time with a UV light.
Ergebnis, grasgrün.
The result, grass green. If we have a problem, we see that immediately. Then we have a red area somewhere. If it's a small problem, it can be taken care of right away. And then we run the engine again to see if everything is okay. This is how they all should be.
Test passed. This engine can continue on its journey. Meanwhile, back on the rotating table, the next engine is being tested. After the test, the engine needs to cool down before the testing devices can be dismantled. A lifter puts the cooled engines on a suspension track that takes them through the paint shop in a specific order. The first station here is the scan cabin. Here, a complete scan is made of the engine and a 3D image is created, which is used for the paint job to follow. In this way, the paint robot knows exactly which version it has to paint, and whether a new part has been added or not. Parts that are not supposed to be painted are taped. Now the engine is painted with a clear coat. Several robots paint the left side first, and then the right side of the engine.
What we see here is that the engine appears to be white. That is simply because we are using a water-based paint and there is still water in the paint. That makes it look white. During the drying phase, it loses that white color and slowly becomes transparent, as we can see on finished engines. In the background is a water wall. The water wall takes the paint particles out of the air. That means that through suction, we get the air in the cabin to go through the water wall. Small particles get caught in the water, bind with it, and are later disposed of as waste.
After less than 60 seconds, the engine is painted. Initially, before it dries, the new coat of paint looks milky white. It takes a few minutes for the paint to dry and become transparent. When everything is completely dry, another quality control is carried out. Here too, manually.
I do a quality check of the entire motor, including the paint job, to see if all the parts have been painted properly. If, for example, a screw thread has been painted, it has to be cleaned. Only then we ship the motor.
To Japan, Russia, or North America, for example. Most, however, go to the factory in Wörth, 70 kilometers away.
Here we see the results of 2,500 parts that are now ready to go out into the world. In this particular case, it's a motor that is going to Wörth, to our own factory where we assemble trucks. You can tell because it is in a steel frame. That is just a carrier, and the frame comes back to us empty, so that we can send out the next engine.
Scene change, Stuttgart. Another location with test benches. Before a vehicle goes into production, the motor, transmission, and axles are tested, not just for performance, reliability, and fuel economy, but also for the amount of noise they produce. Ever more stringent requirements demand that trucks have to be quieter. Even the gear wheels in the transmission are aligned so that they run as quietly as possible. This room is equipped with microphones and sound-absorbing walls.
In principle, it's like being on the road where there's nothing in the way on the left and the right. For the sound waves, there are no walls here. They disappear in that part and are not reflected so that we can take field measurements as if the transmission were on a big field. And all we measure is the sound of the transmission and not the noise reflecting from the walls. So we just measure the source.
Everything in this room is hidden in these sound-absorbing materials. Only the test transmission is open, surrounded by microphones. The purpose of the test? To determine which gear wheel makes noise and needs to be optimized. But the transmission doesn't just have to be quiet. It also has to function efficiently. To achieve that, another lab tests a truck's gear-changing characteristics under full-load conditions day in and day out. This is a truck that drives the same test stretch every day. so that different modes of driving can be compared with one another.
This is actually a vehicle without tires or rear axle. We've got the engine, the transmission, and the exhaust gas after-treatment system.
In this test, the truck drives the route Stuttgart-Hamburg-Stuttgart every day, with different driving strategies. Sometimes the gear changes sooner when going up a hill, sometimes later. This then determines the optimal switching strategy to achieve the best possible fuel economy.
We can drive the route one day with 40 tons total weight, the next day again with 30, and the day after that with 20, and can compare the results right away. Does this gear shifting strategy work with a full load, with half a load, with an empty truck? And then we have a statistically valid result and can evaluate the fuel consumption on the spot.
Back in Wörth. To build more than 400 trucks per day requires almost 550 truckloads of parts, every day, 5 days a week. Everything is delivered here and needs to be distributed with precision.
Logistics and production work together very closely. Logistics is actually at the core of the initial processes because they deliver the parts. They schedule deliveries, procure the parts, and they have to deliver them to the assembly line. Finally, the parts are put into a basket, so every vehicle has the right part at the right place at the right second.
It's like a beehive. Automated conveyor belts move boxes from A to B and back again. To save storage space, only parts that will be used in the next few minutes are placed onto the conveyor belt. This is all backed up by an ingenious logistics system. Every box that is delivered is scanned and then registered in the system. So all of the small parts in these boxes are sorted. The parts carriers are placed in the high rack storage area until they are needed in production. The warehouse is staffed by 12 huge robots, the so-called Automated Storage and Retrieval System, or ASRS for short. They put away all of the boxes that come in and take them out again too. ASRS is there to look after storing and retrieving small parts. These machines can move up to about 35,000 units per working day. No human could do that much. But the boxes are not just stored away. The machines store them and automatically retrieve them in perfect order, so that they arrive at the assembly line exactly when they are needed. That means there is always room on the assembly line. There are never unnecessary parts lying around somewhere. Small parts move around the factory all day long, as if by magic.
We have all sorts of things in stock here, from screws to radios and cable ties. Everything that fits into small containers is stored here, except for hazardous substances.
Not a single screw is lost. The system always knows exactly where each box is at any given moment. Every carrier, in other words, every box, has a barcode. The scanner registers it, and the system then knows exactly where which carrier has to go. The system makes those decisions in fractions of a second. The boxes are sorted into these wagons. Like in a supermarket, they're called baskets. And they are sorted in such a way that the employees on the assembly line can take out the right part in the right order. Small parts are delivered right to the assembly line on the carriers. Larger parts are put into the baskets by hand. If someone grabs the wrong part here, then it will not be available later for assembly. That is why there is a control computer which shows which part is sorted into which compartment in which quantity.
This system has one important advantage. Not only does it show me which parts I have to get, but also where I have to put them in the basket. You can see that here with the different colors, one red, one blue, and one yellow. For the employee, that means that A, he has to get that part, and B, put it in the correspondingly colored compartment.
In addition, each part has its own name. They are called things like Superman, Compass, White Chocolate, or Crossbow. The names are there in case of an emergency. If the computer system suddenly crashes, the employees can work with a handwritten list. Words such as cupcake and crocodile are easier to remember than long parts numbers. This way, even a power outage will not stop production in this department. Once the baskets are packed, they are brought to the assembly line. Once again, that is taken care of by the driverless transport vehicles, the so-called AGVs.
Here we use the AGV to get the filled baskets from the starting point to the processing point, the assembly point. This transportation system simply bridges that gap. Think of it like a train. It drives along its track and has a scanner that recognizes me. That means it stops automatically. Nothing can go wrong. When I move away again, the system continues automatically. It takes a second and then it starts up again.
The interior of the painted cabs is now installed. One of the first assembly processes is the installation of the cockpit. It is delivered together with the cab into which it is to be mounted. Whether it is right-hand drive or left-hand drive, the system always knows exactly which vehicle is next and always has the proper instrument panel ready to go. The cockpit is bolted to the A-pillar and the front end. Using a torque wrench, the employees tighten the bolts with the necessary tension.
We work in 2 shifts, putting in up to 438 cockpits a day. If you add up all the days that people have been working here, then that's several thousand.
Next, a robot glues in the windscreen. The windscreens also arrive at the assembly line in the right order. The robot picks up the windscreen, takes it to the glue nozzle, where the glue is applied. At the same time, another robot is measuring the cab where the windscreen is to go. Then it is put in with millimeter precision. Now the seats are waiting to be put in. They were just delivered, precisely as ordered by the customer.
We have every kind of seat. There is the driver's seat, a passenger seat, and the jump seat. The new Actros even has a reclining seat that swivels, that you can turn. These seats are of course available in a multitude of variations. Variations include leather or partial leather upholstery with or without seat heating, and there is a comfort version, so here too there is incredible variance.
Next are the cab's doors. After being painted, they went to a separate production site for preparation. To ensure that the parts are fastened with the right amount of torque, each bolt has its own cordless screwdriver, thus avoiding mistakes. Now we move on to the interior. The employee installs and connects the cables for the steering wheel in a few easy steps. He uses an electronic torque wrench that measures and saves the bolting parameters in the system. A record is kept on who tightened the steering wheel when and by how much. What is called the bonnet on a family car, here it is called the front gate. 2 employees put it into place and then bolt it on by hand.
To prevent scratches and for better ergonomics, 2 of us work together to put it into place. As soon as we place it, it can no longer fall off. In the second step, it is then screwed down. The next step is the actress sign. We put it on with a template and then press it tightly so that it can never come off again. Well, and then it can be shipped to the customer.
Every 3rd truck on German roads was built in Wörth, every 5th truck on European roads. In 2 shifts, around 11,000 people work here, producing up to 470 trucks a day. Here is where the assembly line reaches its high point, the so-called wedding. This is where the cab is put onto the frame. 6 different models leave the factory's assembly line, randomly mixed. Impossible to think what might happen if the wrong cab showed up for the wedding.
A wedding? Because in this step we are marrying the 2 main components of the Wörth factory, the cab, which is built at the same time as the frame. That is why we call it a wedding, and why it is the most important process for us. The 2 largest components come together.
Next are the tires. Then the truck can finally stand on its own. Slowly but surely, the trip through the factory is coming to an end. In a few minutes, the truck will be finished. Now the employees are filling the vehicle with all the fluids it needs. In a few seconds, they will bring the truck to life.
We're ready. We're now preparing the vehicle. That is, we're pressing diesel into the filter, and once we have achieved a certain pressure in the system, we can have the initial ignition. And that is about to happen. The system's blue light is on. That tells us that there's enough coolant in the vehicle. It works.
This morning, there were about 10,000 individual pieces. Now the 6 cylinders are running, and all the functions will be tested one more time. The last big technical test is carried out on one of the 5 in-house chassis dynamometers. This is the testing ground for every truck. In around 10 minutes, the truck goes through a wide range of tests. Only then is the truck allowed out onto the road. The final check takes place at the so-called paint transfer square. A new truck rolls through these 2 gates every 130 seconds, but only if it is perfect. Every scratch, no matter how small, is located and, if necessary, repaired.
I have a look at the whole thing to see if I can find something, because this is the first check of the driver's cab after the assembly line process. The light has to be that bright so that I can see everything, because if it were dark or the angle of the light unfavorable, you couldn't see minor dents. That's why it's that bright here.
If there is a scratch, the truck is sent back to be reworked. Depending on the part, it will either be replaced or, as in most cases, repainted. The most common problem are scratches on the cabin that were made during the assembly. Those parts go back to the paint shop and are repainted. Scratches and dents are entered into the checklist. Everyone who evaluates the truck later on can see where the scratch was and which part was affected.
As far as I'm concerned, the truck is okay. I didn't find anything. And depending on how much details I have to enter on the record, it takes 2 to 3 minutes to check a vehicle.
Roughly every 130 seconds, a truck leaves the paint transfer square, and so finally leaves the kilometer-long production hall. About 1/5 of the entire truck production in Wörth is loaded onto ships and sent abroad. There is a container terminal right beside the factory. In the past 50 years, more than 700,000 deconstructed trucks, so-called CKD parts, have been sent off by ship. CKD stands for completely knocked down, that is, completely taken apart. The trucks are packaged as a construction kit, either in boxes or, like the cabs, mounted on wooden frames. Special packaging was developed in the in-house carpenter shop.
We use one part to test how we are going to build the packaging. If prototypes are worthy, then we go into mass production, and the supplier who is going to carry out the mass production gets the prototype from us.
With every facelift and every change in the vehicle, the packaging also has to be changed. The goal is always to put as many parts as possible into the least amount of space while ensuring maximum protection. Packaging like that is called colo.
Our colleagues carried out a study for a client in South Africa on tanks. They checked to see if the tanks could be transported safely and damage-free, and if everything fit. A kind of final inspection before we send out the colo.
For smaller parts, there is the so-called shake test, to simulate travel at sea. After all, the boxes being exported travel for weeks on end. Here, the testers can find out if the packaged parts arrive undamaged at the customer's doorstep. Just like in a model kit, the boxes have every part you need to build a truck. To ensure that the customers know how to put the pieces together, the factory offers to come to the customer and assemble the first truck together. When they do that, they also write assembly instructions specifically for the customer's trucks.
The first time they put it together, they do it with the help of our employees. They get their first touch and feel of the truck and take this knowledge with them when the trucks come out of the boxes in their factory. Then it's just an ongoing process.
Every screw is only in the assembly set once. If it is used in the wrong spot, it will be missing somewhere else. With the help of very detailed assembly instructions and an intense exchange with the partners, such mistakes are avoided. All the boxes go to the overseas shipping container and are stored according to a very exact positioning plan. Every box has its predetermined place in the container to avoid imbalances later on.
This one is going to Russia to a customer in Tatarstan, in Chelny. For shipping, it is now going up the Rhine to Rotterdam. From there, it will go by sea to St. Petersburg, and then we'll take it by truck to the assembly factory in Chelny.
Before it goes, employees secure the valuable cargo so that nothing is damaged along the way. Finally, the container is given a customs seal. Now the container can start its trip to Russia. First, a container stacker puts it onto a truck. While this is happening, the container is also being weighed by the stacker. This is essential for the balancing of the ship. An empty container weighs around 4 tons. Depending on how it is packed, it will weigh between 12 and 22 tons. The truck takes the container to the harbor, a mere 500 meters away. There, one of 2 container cranes puts it on the ship. At the same time, empty containers are being taken off the ship, creating a perfect cycle.
The truck comes from over there, from us, from our factory, to the Rhine River harbour. It unloads the full container, picks up an empty one, and brings us the empty container. So actually it's a closed loop of only a few minutes.
Some trucks are picked up personally in the customer center. A lot of times, businessmen and drivers want to pick up their vehicle after a tour of the factory. On average, there are 120 deliveries that are handled here per day. When things are busy, that can rise to up to 200 per day. The employees in the customer center are at the customer's disposal to explain everything about the truck and to answer questions. After all, you don't buy a truck every day. This morning it was 100,000 individual pieces. Now the Actros is ready for the road and is starting its life as a truck. The first drawings and studies on this model were carried out more than a decade ago. Now this truck is at home on roads all around the globe. Andy Sugata played a significant role in designing the Actros before it was introduced into the market. His drawings show how futuristic the vehicle was supposed to look back then. Some elements of that were actually integrated into the final product.
That
was at the very beginning, so to speak. We simply developed completely crazy forms, purely from an exterior perspective.
What remains is the distinctive front of the vehicle. The vehicle had to appeal to a very targeted audience with a strong sense of taste.
The design has to be so precise that you immediately feel it's reliable. It has to look as if it's been formed out of one solid block.
As head of design, Kai Ziba is the man responsible for the appearance of the vehicle today, something which is in principle a large tool. But buyers do not reach their decisions just on the basis of quality, running costs, and performance. The truck has to grab them right from the start.
Everything that the truck can do, it has to show that it can do. The design has to be very honest. It's really true. Form and function interact. There is no superimposed styling.
It is the largest truck factory in the world. Almost 11,000 people work in an area covering 2.9 square kilometers. Since 1963, the factory in Wörth has been producing up to 470 trucks per day. Every third truck on German roads was built here. Every 130 seconds, a new truck leaves the assembly line. The engines for the trucks are produced in the company's own engine factory in Mannheim. Self-driving robots transport heavy parts from one station to the next and ensure that within the space of a few hours, a diesel engine is created from 2,500 individual pieces. In Wörth, more than 550 truckloads of parts arrive at the factory every day, stockpiled in a huge high-rack storage area. 35,000 boxes are moved in and out here every day. On the assembly line, man and machine work hand in hand to assemble the trucks. And in less than one day, a truck is assembled and can leave the factory. 1/5 of these are taken apart and shipped as a construction kit overseas. They leave from the container harbor located 500 meters from the factory. 5 days a week, 2 shifts per day. And tomorrow it's back to the beginning when the next morning shift starts in the largest truck factory in the world.